Hello, and welcome to another edition of the Real Estate Edge. Man has built homes and other structures since the beginning of time, but advanced technology has finally caught up with traditional building concepts. It's called 3D printing. To help take some of the mystery out of this subject is today's guest, Don Ajamian, CEO, Emergent 3D from Redding, California. Don, thank you for being with us.
Thank you so much, Gary. Thanks for having me.
Indeed. Let's start by telling our viewers, what is a 3D building?
So a 3D building, it's similar. If your viewers are familiar with 3D printing, what they may be familiar with is the desktop version that's about the size of a microwave oven, and it heats up plastic to build a 3D model or a toy or some accessory part or something like that. And typically, what most people might be familiar with is, that desktop version, right? That heats up plastic. But nowadays, there are all different kinds of elements that are being used. In fact, in the medical industry, they are 3D printing human organs for transplant even. And in our case, we are using cement, and we are using a piece of machinery that is the size of a house, and actually extruding concrete to layer up the walls of a house and literally 3D print a house, full-size house on site.
That's amazing. How long has this concept been around?
So it's been in some form of research and development for really a couple of decades. It's only been commercially available over the last few years, where you or I or anybody that wanted to get into this business could actually buy one. Other than that, it's just been several different, independent researchers and some universities and private parties that have been developing the technology. But, for commercial viability, it's been around for about the last 5 or 6 years worldwide.
Is there a point of origin, or where did the idea come from?
Boy, that's a tough question. It evolved. Again, I've seen the little plastic 3D printers for years. I'm a general contractor. I've been building for a long time, and even years ago, call it even a decade ago, when I get a very complex building structure, there were times that our architect would 3D print a model of it, so I could hold it in my hands and I can look at it from all sides and really see what he's trying to get across to me with his two-dimensional blueprints. And so it's become a very useful tool. And again, it's just become a matter of time that people have used that very technology to go into these different areas like concrete 3D printing.
How long have you been in the business, Don?
So I've been in the construction business for full-time for about 37 years. But in the 3D printing business, we just started this about 3 years ago. In 2018, here, I'm in Northern California in the Shasta County area. We had a major fire that we lost about 1,100 homes here in Shasta County. And I was asked to serve on the recovery committee. FEMA came in and handed us this notebook that was about 2 inches thick that described exactly how communities like ours would recover after a disaster like that. And part of it was to create this long-term recovery team that I was asked to head up the construction subcommittee for. And it was during those times we would meet once or twice a week for a couple of years. There were some 300 properties that were lost by folks that were either completely uninsured or severely underinsured and would have no way of rebuilding. And we had to try to find them solutions. We had to try to, there's a severe labor shortage and material costs. And also we were looking desperately for solutions, and 3D printing of construction checked all the boxes.
What was the attraction to you to make the transition after spending over 37 years in traditional building? There had to be one sort of initiative that sort of caught your thought system and kind of your contractor background that said, yes, this is the future.
So actually, I'd say there were two or three really significant factors that attracted me to it. First of all, as I said, it addresses many of my current pain points. One of the stats I read recently is that for every five of me that are retiring out of the trades, there's only one coming in. And so, in
Really?
my simple mind, that means that we've got to try and automate 80% of construction just to keep up, right?
Indeed.
So, the fact that we can automate part of the process, certainly we're not going to automate 80% of it just with this one new technology, but the fact that we can automate some of it isn't going in the right direction. Secondly, it's a construction tech job. And whenever we've done presentations for a younger demographic, and they realize that now we're offering them an opportunity to do construction with their thumbs, they're really quite attracted to that idea, right?
Of
It's
course.
they don't want to dig ditches, but boy, it's a technology job. So we're gaining some interest in the younger demographic. But one of my the favorite parts of it for me that really pushed me towards this direction is my entire career has been defined by straight, square, and plumb. Everything you
Yes.
build is has to follow those dynamics. And now with 3D printing, we can do these curves and organic shapes actually quite easily. And one of the stories I'll tell people is if I was to build a square building, for example, that was 50 feet by 50 feet, that means I've built 200 lineal feet of wall and I get 2,500 square feet out of it. But if I did a 60-foot diameter circle, that's 188 lineal feet of wall. So I've got less wall footage, but I'm up at around 2,850 square feet. So I've gained free square footage. And I'm not suggesting that we should all live in round silos, but the lesson is we can bow out walls and we can do things that previously would have been quite cost prohibitive. But now we actually reduce our cost per square foot because we're gaining this free square footage by doing so. And this
Sure.
technology offers that to us.
What are the requirements to become a 3D builder? That is, what kind of change did you have to go through to accept this concept and all of a sudden move in that direction?
I think to get into it at this phase, you probably have to be maybe a little bit crazy. We're inventing an industry in a sense. Nobody in California has
Yes, you
done
are.
this yet. So there's a lot of this that we are figuring out. One of the things I really love is that the 20 somethings and the 30 somethings figured out how to make the computer talk to the big machine. But I feel like it takes my generation to bring some livability to the structures and bringing some of that old world, craftsmanship to it. So, I mean, I think there's a lot of things. I won't get too deep into this, but I'm in my upper years of my career, and so this has reinvigorated me. There's just something exciting about this. Where again, I was serving on the recovery after our big car fire, and so the fact that we can create homes that are not only aesthetically very beautiful, but we can do them in a shorter amount of time and we can do them for less cost is quite attractive to me. And so our focus at Emergent 3D anyway is with disaster recovery, with homelessness, transitional housing, and workforce housing. That's a huge one for me. For many years, my very employees could not afford to live in the homes we were building. Maybe now they can.
Does this transition require a big financial investment for you and other contractors? And did you have to spend a lot of time in the classroom in
I
preparing?
did, yeah. Yeah, that's for sure. It's been 3 years since I've been pursuing this along with my business partner, Matthew Guile. He's the original founder of the company. We've been pursuing this hard for 3 years, and we have yet to see any revenue from this. We've invested a lot of time. We've invested quite a bit of money. All of our the equipment that we purchased to pull this off, just for the one setup, was on the plus side of $1 million. So there is a significant investment.
Indeed.
And there's been significant training involved as well. I personally spent 2 weeks in Denmark with the manufacturer and getting some training there on site. I've traveled to several other states and even up into Ontario, Canada, to visit with other builders that are 3D printing, just so I can gain some knowledge there, and then ultimately just starting to build our team. And as I said, in 3 years, we've not received any construction revenue aside from investment revenue that we've gotten as a company.
Are there many 3D builders throughout the country? Or you said there are none in California that you know of, but are there others throughout the country?
So to be fair, there is at least another one in California, but they're not doing it on site. They are doing 3D printing inside of a factory where they will print parts of a building, and then they truck them down the highway and you assemble it on site. So that does exist, but for on-site construction, so far anyway, we are it in California. But I do know of a company in Arizona doing it. There is a company in Florida doing it, a company in Texas doing it. I believe in Virginia and New York area, there are companies there as well. So we're certainly not the first in North America. We just happen to be the first on-site 3D printer in California.
Sure. Well, it sounds like you're certainly one of the first leading the this development. What type of building material do you commonly use? Just normally everything that's used in a regular structure?
That part is true, and I know at some point I'm certain we're going to talk about the cost and the cost savings, potential cost savings. So many of the materials in a 3D printed home is the same as the materials in a regular home. You still have roof trusses and roofing and cabinets and doors and windows and electrical and plumbing and appliances and so on. And as I'm sure you and your viewers know, those costs have been doing nothing but going up.
Certainly have.
For our part, we are using conventional Portland cement. And so we batch the material on site. We're not having cement trucks come. We actually just have sand and gravel and bags of cement and water and some other additives that make it printable. And we mix our own material and we extrude that. And the beauty of that is that it's a material that's already, code approved. It's structurally been tested, for decades, and so we can use it in our design, and even in our structural elements, we can use the material that we create right on site.
Were there any challenges meeting specific building codes initially?
Yeah, so when Matt and I first started, and actually I should back up a little, when Matt first told me about this idea, because it was originally his idea, I thought he was crazy. I thought that maybe this would be acceptable in some third world country somewhere, but certainly not in California. My entire career has been right here in California, and we have quite a history with these unreinforced concrete buildings. When there's an earthquake, they come crashing down. And so there's been quite a cottage industry in California of retrofitting buildings for the current seismic codes. And so I thought it would be quite a challenge to make that happen in California. Now, there are researchers and there are companies that are working on getting 3D printing to be code approved, and they are spending hundreds of thousands of dollars, and it's going to take them years to do. And I'm encouraging them from the sidelines. I want them to do it because that's only going to benefit us all. However, our design utilizes currently approved code approved methods for doing this. And so we are literally 3D printing, I guess you could say we're 3D printing formwork within the cavity of our exterior walls, and then installing rebar and filling with concrete to create columns. And if you could imagine it, if you imagine a concrete parking structure that's got pillars and then concrete pillars and concrete beams, virtually that's what we're building, We're just finishing out the skin to create a completely enclosed structure.
I see. How would you summarize the benefits to the consumer of 3D printed homes or other buildings for that matter?
Yeah, so a few of the benefits. Again, the one that excites me the most is the design palette that it offers. As I said earlier, we do not have to go straight, square, and plumb. In fact, the 3D printer can curve. A 3D printer can print a radiused corner much more smoothly and easily than a 90-degree corner, because to do a 90-degree corner, it has to stop, realign, and start again, and it creates a little bit of an ugliness when it stops and it leaves a little tail, and then it starts up again and it leaves a little squirt. But if we could just curve right around the corner, it just looks beautiful and flowing, and that's not something we can do conventionally. So we are pushing our architects to create wild concept designs that incorporate curves and these organic shapes. So that, to me, that's the biggest benefit. But there are others. We save a lot of time. When we print the walls of a house, for example, as long as the homeowner is okay with that aesthetic, that is not only the structure, but it's the exterior finish and the interior finish. And we can paint it and we're done. So we don't need drywall or cladding on the inside. We don't need stucco or siding or anything else on the outside. Now, certainly those things can be added, but we could save a lot of time. And again, when we're talking about workforce housing or homelessness transitional housing, that's where a lot of the savings in cost can come from, is that we don't have to add finishes to our printed wall. So there's time savings, there's some cost savings, there's the design palette. And the last one I would say is the insulative factor of our printed walls. When we 3D print any wall, we actually print the inside and the outside of every wall. Think of it as the skin, the layers of skin on the exterior and the interior. And we leave an air gap in the middle. And that air gap is for plumbing and electrical. And on your exterior walls, that's where you would have your insulation. The beauty of this design is that we don't have a thermal bridge every 16 inches like we do in conventional construction, where you have your studs every 16 inches. That is the most vulnerable part of your energy envelope, is wherever the studs are. Having that gap in the wall means that the outside face can cook and the inside face would be cool to the touch, because you don't have any bridge connecting that. And so here in California, they've got some fairly strict energy codes, and our first approved home actually beat those energy codes by about 30%.
Really? Well, it sounds like there are many benefits, including cost, which is a major consideration in today's environment. Can you give us an idea what type of structures can you build? Obviously, conventional homes, residents. What about commercial buildings or multifamily, different structures that require more material and a little greater effort and design?
So certainly we can. We are in final design steps and building department approval right now on what we believe would be the world's first 3D printed church. And that it's a 6,000 square foot. It's a 6,000 square foot building. Our machine is big enough in one setup to print 3,000 square feet. And we can do up to 26 feet tall with our machine that we have set up. So in order to do this church, we'd actually have to set it up twice to print the building. But one of the beautiful things that we discovered along the way, and I'll tell you, I've built a few churches over the years in my conventional construction company. And the thing that all churches have in common is that money is always tight. Money is always an issue. And we get to the end of the structure and we end up with this facility that now, when money is tight towards the end, they can't really afford to really properly acoustically treat their main sanctuary. You know, the sound reinforcement, the sound baffling that's required could cost hundreds of thousands of dollars. So what we've done in this church that we're in design with, our architect actually reached out to an acoustical engineer, and he designed the shape of the walls at the inside of the main sanctuary to be shaped like tall curtains. And so literally our 3D printer will print this shape that the concrete will look like curtains that are tapered from top to bottom, and they will
Amazing.
articulate up to 6 inches deep in and out. And in the computer, at least, what he's saying is that that sanctuary, which will seat about 200 people, that the pastor should be able to just stand on the podium and talk and not need a microphone, and people will understand him perfectly because the room will be acoustically tuned right out of the print head. And it costs very little extra material, very little extra time, and we get to acoustically treat the room. So just kind of this side benefit. And so I think about the applications on that in other areas, perhaps a home theater, we can acoustically tune a home theater, or perhaps a factory that's very noisy. If we can print this industrial building in such a way that we can minimize certain sound waves that are harmful to us, what a benefit that could be.
Indeed it is. Don, given the current technology and your equipment, what are the size limits, either laterally or building up? Are there? I presume there are current limits. For example, how many stories can you build currently?
Yeah, so with the machine that we own, we can do a 2-story building. We can go up to 26 feet tall print height from zero. So we could do a 2-story building. The church I was just talking about, I think the walls are around 21 feet tall. However, our manufacturer, which is Kobod out of Copenhagen, Denmark, they actually, a minority partner of theirs is General Electric. And one of the reasons that GE invested in them is because they're in development for what they call their XL machine. And their XL machine can actually print, I want to say 60 feet tall. And forgive me, I'm not sure how wide, but the point of that development is for the wind turbines. They can't build wind turbines any taller than they do right now because the steel base would be so wide they can't truck it down the road. So now they're talking about 3D printing the base on site. They could 3D print it and then install their towers, and they're able to get up an extra couple hundred feet and get that the higher trade winds. And so it's constantly evolving, it's constantly growing, and that's the exciting part about it.
Fascinating. Today, if an individual has their own plans, their own specs, and they want you to build either their home or a commercial project, for example, a warehouse or manufacturing plant, you're prepared and you have the systems to do that. Is that a fair assumption?
We do.
Even though it's their design.
Yeah, we do. We can do that. Now, there's going to be some elements of it that we would change slightly, just because of the capabilities and perhaps the limitations of 3D printing. For example, even interior corners, we are best off to make them a tight radius as opposed to a tight a true 90-degree corner. Mm-hmm. So there'd be small elements that we would change. But to be honest, if somebody designed a home, they drew it out on their graph paper, whatever they did, and they really want that straight, square, plumb type of look, they may be better off to build it conventionally. Our encouragement is, let's use this technology for what we can really do. And so
sure.
The odds are our architects would take what they've designed and maybe put some 3D color into it, put some of the bells and whistles that 3D printing can offer, sure, to make it work.
Are jurisdictions somewhat reluctantly accepting this concept as you as you go from jurisdiction to jurisdiction, county to county, do they have different standards and different? Is it readily acceptable, I guess, is what I'm trying to ask.
So it's starting to be, and if I can tell you a little funny story about that one, before
Sure.
we ever had our plans approved in California, we did a presentation for the leadership of the city of Redding. It was the city manager, the assistant manager, the building official, the fire marshal, and several of them. And we're telling them how we can help address, some of the car fire recovery needs that are out there. And oh, and by the way, if you will work with us, we could have the first on-site 3D printed house in the state of California. And the city manager literally stood up out of his chair, put his fists up in the air, and said, "Yes, we will be the first city in California to have a 3D printed house." And the building official, as the city manager was saying that, the building official put his head in his hand. He says, "Oh my gosh, I have to approve the first 3D printed house in the state of California." My experience has been that anytime we present anything that's new and different, the first question the building official will ask is, "Show me where it's been done before in California, and we'd be happy to look at what they did." And so this time we didn't have that luxury, but the city manager put out his word, and so he was forced to work with us, and they had 3 of their structural engineers. They actually pulled one of them out of retirement, and we had our couple of structural engineers, and they worked very hard. It took them a couple of months to get through it, but we finally did get that approved in the city of Redding, which I'm so thankful for their dedication to do that.
Indeed.
We then took that plan to several other jurisdictions here in Northern California, and they had the luxury of seeing what somebody else approved, but they all had a few questions. In every case, though, I can tell you that they've been excited to look at it. They've heard about it. They were excited to look at it. They loved the idea of bringing this not only to their community, but it's also our heart to raise up and offer training in the various communities to raise up a workforce right there in their communities as well. So they've been quite enthusiastic about it, from my experience.
Oh, that's great to hear. Don, approximately how many structures have you built to date?
If you're talking conventional construction, probably thousands.
I meant the 3D. Sure.
And that's what I thought you meant. So to date, we've built a grand total of 0. We've got our first machine just arrived in California about 2 weeks ago. The team from Denmark is here now. They literally got here on August 22nd to start our on-site training, and they will spend 2 weeks with us. And so we will literally start printing our first home the week of the 29th, of August 29th. We'll start 3D printing our first home.
Okay. And then after that, is it your vision that you'll do homes throughout the state?
Yeah, we will. So right now we are contracted to build that first home that we got approved and then approved in several jurisdictions. We call it our wildfire restoration home. So that's the first one we're printing now, and we will print that same home a total of 7 times in a row. Several different sites within the city of Redding, and then we're also doing that home a couple of times down in Paradise. After the car fire, where we lost about 1,100 homes, just a few months later, Paradise had a fire known as the Camp Fire, and they lost some 14,000 homes. So their need is still very great, and we're just so looking forward to putting our first wildfire restoration house up there later this year.
Sure. Well, Don, we're just about out of time, but I have one more question for you. Put your futurist hat on. What do you see the future of 3D building? If you were to look out 20 years from now? How will it change? What will that be the only method of construction that's sort of acceptable to the professional contractors?
Well, I don't know that sticks will go away. I don't know that it will be the only way. One of the things I see, and it's not going to take 20 years to do it. NASA actually is involved in 3D printing because they would like to be able to 3D print installations on the moon and on Mars. And so
Really?
with NASA, yeah. So with NASA involved, they brought us things like Velcro and some of the other stuff that's very common. But I can't imagine that NASA is planning on loading up a bunch of sand and gravel and water and cement into a rocket and taking it up there. The way it's going to work is that they'll be able to grab whatever native material is around them and create a process for using that to build installations, to build structures. So as I think about that technology, which I don't think is 20 years away, I think it's maybe a handful of years away. When I think of that, I think of the third world. Think of the deserts. Think of places that have resources all around them. And if we can adopt a technology that gathers those very resources and uses them to build structures that are safe and secure for folks, that's one of the things that I see in the future. And the other one I would say is that 3D printing, it's just a tool. It's a means to an end, but I see more robotics coming into construction. There are companies today that are creating fully autonomous painting and plastering robots. There are companies developing all different sources of robotics, and these aren't job killers. These are job creators. The way I see it, and we didn't get into this, but a lot of people look at this as perhaps we're taking jobs away. There's a severe shortage of labor help, and it's only getting worse. So by automating, we can not only leverage the limited resource of employees and workers and the limited resource of money, and we could actually create more homes with it. And that's the ultimate goal, is that we can leverage this technology to help address a very important housing crisis.
Well, that's exciting, and it seems that 3D printing is going to play a major role in providing housing and other structures in our future. That concludes this episode of Stringham Real Estate Edge. Today's program was brought to you by Stringham Schools, educating real estate professionals since 1989. Visit stringhamschools.com to learn more. We want to thank today's guests, and don't forget to tell us what you think in the comments section below. I'm Gary Barnes, and I'll see you on the next episode of Stringham Real Estate Edge.